So, thanks for coming, first of all.
I'm happy to be here. It's a nice place. I was already here, but it's a super place to do research.
We're trying to do our best. Now, speaking of research, as I mentioned, so let's start at the very beginning, right? You are the co-author of the long short-term memory paper, which is was extremely influential. So part of the crowd, of course, knows exactly what this is, but part may never have heard of it. Can you explain in a language that's accessible to non-engineer what this is and why it was such a big deal? Like what kind of problem did you solve at the time?
Yes, this was a time where we played around with neural networks. So they were very small. They had a couple of neurons, some hundreds of parameters, weights.
This was in the 90s.
It was end 80s, beginning of the 90s. And there was a fascination about recurrent neural networks. These were neural networks who can memorize things, but they did not work well. There was an excitement. If you think back at guys like Jeffrey Hinton, Joshua Benjo, there was a big excitement. But the neural networks were hard to deal with. Even harder were recurrent neural networks which can memorize. There was a problem if you say a man goes over the street, the neural network could only memorize the street, did not memorize there was a man. And with long short-term memory, I solved the problem that recurrent neural networks can memorize information over a longer period of time. Now, the neural network can also memorize in this sentence, there was a man at the beginning of the sentence. And this was with the vanishing gradient, which was also a thing you have to overcome to build deep neural networks now, going over the layers. At this time, it was going over the time. Over time, you forget things. Over the layers, you lose information. That was one of the fundamental problems there. And with long short-term memory, I solved this problem for recurrent neural networks.
And like, were you so? Can we put us in your shoes at the time? I mean, were you aware what this was gonna unleash? Were you? I mean, if I understand the history also correctly, it actually took also quite some time because you were so early. It took quite some time for the impact of that breakthrough to really sort of manifest itself.
Yes, I was not aware of that. First, also my supervisor, Jürgen Schmidhuber, who worked a long time here in Switzerland, I was not aware of it because it was in the later part of my diploma thesis. And at that time, neural networks went down. Things like support vector machines came in. And as we published it, or we tried to publish it at a conference, the conference was called NeurIPS, it was rejected.
It was rejected.
If the supervisor did not see it, it gets rejected. You don't feel it will have an impact.
It's and a big breakthrough.
And if then other topics come up, you less get the feeling it will have some impact. I never expected this, of course.
But when it then happened, I mean, there must have been a moment where you realized, okay, this thing actually, this is going to have massive legs.
Yes, there was an interesting moment. As I was at this conference, NeurIPS, there was this big guys like Geoffrey Hinton. I had a poster, and Geoffrey Hinton went by. My heart started to beat. Perhaps he will look at my poster. He did not. But at least I could breathe the same air as he did. So I was very proud of that. And years later, 2000, I think it was 2011 or 12, something like this, I went again to the same conference, NeurIPS, and Geoffrey Hinton ran at me and said, hey Sepp, do you know all these guys are coming to the conference because of your LSTM, because recurrent neural networks are working? And I was, wow.
That's great. So now you're, if I understand correctly, you're working on an updated, or you have been working on an updated version of that technology. Just tell us more about that.
Yes, that's true. LSTMs were the first large language models with Elmo and stuff like this. And before, every big company, Amazon, Google, Microsoft, Baidu, whatever, used LSTMs for speech and text processing. But 2017, there was a paper, it was called Attention is All You Need.
Yep.
It's a transformer technology came in. It had a big advantage. It could be parallelized. It could be parallelized during training. Therefore, you could learn on more words, on more text at the same time. And it overruns the LSTM technology. Everybody used the transformer technology. But there was always something, what would happen if we would have done the same with LSTMs as was done with transformers, to scale them up, to make them bigger, to make them parallelizable, make them bigger, give them more memory. And this we tried many years later, but here we encountered the next problem. We saw, yes, we call it now X-LSTM, there could be an interesting thing behind the LSTM, but we could not prove it because you need money. Therefore, we founded this company, NXAI, together with investors to get some money to try it out, to see, can we scale up LSTMs? Can we get at the level as transformers? Yes, we could, but not for the very big networks, now up to 7 billion network, where we could scale up. But we have a huge, huge advantage with the technology, with the old technology, the technology of the early 90s. We are faster in inference. While the transformer is quadratic in the number of words it's producing, or you give us prompt, LSTM is only linear. This could mean, depending on the context length, we are 10 times faster or 100 times faster. And in these days, where inference plays a big role, perhaps you heard about O1 or 3, or recently DeepSeek.
DeepSeek R1, yeah.
DeepSeek R1, they're doing a lot at inference time. And we are much, much faster with LSTMs in inference time, of course, depending on how long the context is. And I see a huge advantage to use this new modern LSTMs, the X-LSTMs, for the things what's going on right now, doing more thinking, doing more at inference time. And also, because we are here in applied machine learning conference, because we are so fast in inference, we can go into other domains, not speech. If you think we can go in embedded, like self-driving cars, robotics, stuff like this, you need fast models, because a robot cannot wait, do something, wait a couple of seconds and do the next movement. There the speed is really, really essential. Or in real-time application, like you have a digital twin at your production system, it should be fast. It should be real-time with your process and perhaps predicting if something going wrong. Therefore, with this new technology, we can now go into domains where we here in Europe, in Switzerland, are very strong in engineering, where the transformer technology cannot go because it's too bulky, it's too slow, it's big and slow, and you need fast and memory efficient technologies. XLSM would do this. Therefore, it's ideally suited to go in applications. Therefore, I'm here.
Yeah.
Because here are the guys who can use it, implement it, and become very, very rich.
Okay, I will show you then in 9 years the share graphs of. Let's open it soon to questions also from the audience. But I have two more before we do that. So one is maybe a small one, but So this sounds extremely interesting. I mean, solving this quadratic issue, and as you say, I mean, we're now entering this age of reasoning or thinking. I mean, to the extent you want to anthropomorphize things, which is extremely compute intensive. But you say you basically have a solution for that. So you feel like do people realize that, or you feel like you sort of have a deja vu where you now have to go and sort of spend 10 years convincing of this technology, or is the uptake now much faster?
At least I have experience to wait until others understand the advantage of my technology. But yes, I see a big advantage, but of our method of XLSTM. But the big tech companies have a much louder PR machinery. If Google or Microsoft, OpenAI launches some announcement, some achievement, everybody is looking at it. So it's hard to say, hey, perhaps you're setting your money on the wrong technology, because it's just too energy inefficient. It's just too much compute. You could do it cheaper with less energy, but they are committed in a certain thing of technology, and it's hard to change it. I see it again, like with the early LSTM, but on the other hand, it's a very clear advantage, and companies who want to make money, who are in engineering, will use the technology which is working, which is fast enough, cheap enough, energy efficient enough.
Yeah, sure. And I mean, at the time when you came out with the first version, I mean, yeah, as you say, I mean, the whole field was still in its infancy, and now it's a huge economic activity. Yes. So that should accelerate that. So the last question I have before we go to the audience question is also looking a little bit from a I don't want to say geopolitical, maybe geo-economic angle. So you're based in Austria.
Yes.
So what's that like? I mean, I know what it's like in Austria, but I mean, for sort of cutting edge AI company, is that like how well can you operate from sort of Central Europe? Because everyone always tells the startups they have to go to the US. I guess nobody recommends to go to China, but we all know those are sort of the two powers to be. How do you look at this?
Yes, in Austria we also have the Alps, but we don't have the computer, which is really missing in Austria as an infrastructure. Yeah. We are not as well equipped as you here with infrastructure, in particular with compute, but also you have in Zurich, Lausanne, Lugano, you have the big institutes. You should be proud. That's really good. It's not so good in Austria, but for like with the XLSTM, for really pushing it, so public money was not sufficient. Public money was not sufficient. We have to go to private money. We have to found this company NXAI and get private investors to show with compute. We invested at the beginning 10 million euros in compute only to show for smaller models we are there.
Yeah.
In the 90s, you're sitting in front of your PC in a dark room because, computer scientists and vampires should not see the sun. And we did our thing, we analyzed our thing. Now it's completely different. You have to have this big compute infrastructure. You need a big team to set up the runs and stuff like this. And that's what's best done in a company. And also what should be done here and in Europe, build companies who can do the compute, who can invest some money, because you cannot do everything with public money.
Yeah, makes sense. So okay, let's take a few Q&A questions. Maybe the first one here. So you spoke about these this new compact technology. So can 100 of these small LSTM-based models beat any large transformer?
To build a large transformer, you only need a large XLSTM. That's sufficient. And also, I will show you in the afternoon track probably a scaling law. If you have a certain amount of compute, then with an XLSTM, you always can beat a transformer in terms of performance. If you want to have a certain performance, you always can beat the transformer by using less compute to get to the performance. I will show the scaling laws where you see an LSTM always beats a transformer. The idea is you have to build a larger with more parameters LSTM, but it uses less flops, it uses less compute. You have more parameters, but because of this expensive attention mechanism, and we have an inexpensive LSTM inside, we can spend compute on more parameters. Therefore, we build a little bigger model, have the same GPU running time, but get better results. And this is fantastic. Give me any transformer, I give you an MLSTM, an XLSTM, which has the same performance but needs less data or needs less compute, or vice versa. Give me a compute, I beat every transformer in terms of performance with this given compute.
All right, that's a challenge. So you heard the man. Take him up on it this afternoon at his track. So there's a question about the significance of open source initiatives and the collaboration with academia. I guess there's really two questions, but maybe you can speak to each of them. So first, the importance of open source initiatives, how you look at this, and then maybe later we can just briefly talk about the collaboration with academia, which of course you as a professor at the university know something about.
So first, we put everything in NXAI open source, which was a fight because economists in the company, there's the guys who want to make money, don't make it open source, but open source I think is the only chance. You have to include the community in your projects, you have to include everybody, and otherwise other open source projects will overrun you, will be better. And this will happen to OpenAI, this will happen to everybody. Here what Jan Lequin is saying all the time, the open source includes the whole community and is stronger, will build larger, better models. Therefore, I'm completely for open source because it includes everybody, you can work with everybody. The challenge is, because there are some guys at the company who want to make money, still to make money. But there are ways still to make money, even if you give everything open source. Or not everything, the main thing open source, but special solutions perhaps not open source. How the company collaborates with academia, that's also a nice thing. We put the company is financing projects at the university, which is nice for me to bring the university IP rights into the company. You have a project at the university. There are some guys working. If they're very good, they can go to the company, but also the IP is going via these university projects into the company. Otherwise, it's unclear for me, also professor, you have some IP generated at the university, how to transfer it to the company. And the university cannot use the IP, they don't sell it or make patents.
No, that makes sense. Maybe can I just quickly ask you about your opinion on open source in general? I mean, there is a view, it's been quite subdued recently, but I think at the beginning, you know, sort of post ChatGPT, where some people, especially sort of in the safety community, were really concerned about open source, right? They said, this is a dangerous technology. If it's run by a bunch of companies, we can rein them in, right, through legislation. If it's open source, right, all hope is lost. Have you ever taken a position in this debate?
Yes, that might be a danger. Everybody can use it, but the guys who want to use it can use it anyways in some way. But if it's open source, I think there's less danger because if it's proprietary, you don't know what data they used. For example, for the large language models, do they exclude some facts? Do they include political or religious text in it? If you see on which data they trained, and that's also for me open source, you have to reveal what data you use. I want to see the data, the training architecture.
Yeah.
Then you can see where the dangers, also for our kids are they're using this large language models from US. So you get also the US moral, you get the US ethic things, you get all this American culture, because if you ask something, your large language... Yeah, it's Chinese. If you use Chinese, if you now use DeepSeek, you get answers Chinese or American would say, and not the answer a European would say. And yeah, there I see more danger. But I still am from open source, even if everybody can use it. But I don't know. I don't think you can build this new big LLMs hidden somewhere as a terrorist.
Not possible. Yeah. Yep. Good. All right. So there is a question, I guess, again, more about geopolitics. I don't know if you know much about where Switzerland stands, given that you're based in Austria, but maybe, just to take this question and make it a little bigger, I mean, do you think, like, what's your recommendation for Europe? So, I mean, we have strong ecosystem here. You're building things in Austria, as we just heard these past few days. France is really pushing forward, and I think they have a lot of great ingredients. And of course, there's many other European countries. It seems like there would be an important role to play for Europe. Can we and will we?
Where we are strong in Switzerland and in Europe is in having new ideas in research. Many of the things we now see in large language models, what we see in deep learning, came also from Europe. Publications we did here, like stable diffusion from Munich. Our LSTM and Jürgen went to Lugano. All this research was continuing here in Europe, in Switzerland. But where we are weak is putting this technology into companies, build up new startups, and here we have to do much, much better. And also building up the infrastructure. I think you're doing good with apps and so on. You have the brain power here. You have now building up the infrastructure in Switzerland. Also, I hope we do it in whole Europe. But still, you need some mindsetting to bring it into the companies, to use it, to adapt the new technology, like as it was with computers. You see the computers out there, some companies were using them, others are still working with pencil and paper. Yeah. Now you should not use pencil and paper anymore. You should use a computer, or in this case AI, and it's hard for me to bring this technology into companies. Here we should do better.
Yeah. Still to this day, you find it hard.
Yeah.
Interesting. So we would have more questions. Many of them are also fairly technical and they're super interesting. But I guess in the interest of time, we have to move on. And I would just suggest to the people who have posed these questions and liked them to go to the track that Sepp is part of. And you can find that, of course, in the program.
I'm around here. You can find me.
And you're around. So thanks again for everything, and thanks for coming. And yeah, we're glad you're here in this ecosystem.
It's a pleasure. It was nice.
Thank you, Sepp.